Hello and welcome to TRX Bench. Yes, as you already can see, we have again an Albrecht AE497w here on the bench, and that is a 25 watt version of a 10 meter radio. So that is AM, FM and SSB. So that radio came in, and if you have followed my channel, you've seen that we had recently exactly the same radio, which we had to align and so forth. And this one came in, and well, the owner told me that nobody can hear him on the band, so he believes that there might be no TX audio, no modulation, whatever. So that was not totally clear, so we have to check it. And additional to that, the radio has a prior repair attempt. So that is what we already know. Well, what we already know as well. Very funny. So let's go right into the video. Okay, and here we have it. And as I told you, a prior repair attempt, and that ends like this. So all the screws are missing, and yeah, the radio is still not working. So let's see what we can find. Okay, so first let's have a look into the radio to see if something looks damaged or so. So sometimes we easily can see that there was a golden screwdriver in. So let's see if we have something like this here. Well, but from the first look, everything seems to be normal, so no, not really. Okay, so let me hook the radio to mains, and then let's see if it works or not. Okay, so let's switch the radio on, and oh wow, so the radio already has the yeah, it is LED conversion by the looks of it, but yeah, so that is not the warm white version, so that looks like a cold white LED version. Anyways, so it yeah, we have of course here the conversion from the light bulb to the LED, so that is really not bad. Okay, so yeah, so we have been told maybe no modulation, so or minimum nobody can hear me on the band. So what is it? Okay, and the easiest way to check for that is on SSB or AM, whatever. But SSB might be the best idea, because only with modulation we see that we will get output power, right? Alright, so let's try it this way. So you see the watt meter, and alright, so we see here, it is not the best camera position. Let's see it if we can do it this way. So when I press here PTT, you see that our TX indication is coming up, right? And of course we have to set here our microphone amplifier. We set it here simply to, that is a microphone amplifier, and we set it to max, the microphone gain, right? And with the microphone gain to max, let's go here back to this picture, so I hope you all can see my LP500. And now we go on takes and try to modulate. 1 2 1 2. Wow. So what you see is we see nothing. Wow. Okay, once again, 1 2. So you see a peak, but that is, I mean, it is on fast attack mode. So, but we do not have here any modulation. So let me go over here to so waveform and power. So let's see, 1 2. You see that is when I press here my PTT, so that is not any audio, but you see that the power amplifier, so the transmitter is coming up. Yeah, definitely. But 1 2 1 2 1 2, no audio. So now the question is, do we have a problem with our microphone, or is it something really inside our radio? So let's simply go ahead. Okay, so first we check our microphone. So that is a Magnum socket, which is right, and what we already can see is that our RX LED came up, which is right. If I press PTT, there we have TX, so that is all fine. And now let's see here. 1 2 1 2. Hola, audio 1 2 3. So that is very obvious. Our microphone is working just fine. So that definitely means something is wrong here with our radio. So let's go ahead with our radio. Okay, and since this microphones have electret capsules inside, we know that those capsules need a voltage, and so that is what very often happens for a reason. You know, the voltage is gone, and therefore that is the first we want to check out if that might be the case, right? Well, therefore let's have a look into our schematic first, and what we see down here. So that is our microphone, right? And you see here our capsule. And what we see here is that this capsule gets obviously voltage, but we cannot be sure as long we have not checked how it is connected here in the radio. And therefore let's go over, and that is our microphone socket in the radio. So let's see how it is connected here. And down here you see maybe a little bit more enlarged, maybe. So what we can see here is our power switch, right? Let's go a little bit over to the right. And you see here the power switch, and when we switch our radio on, you see that our 13.8 volt, whatever, gets over here our power switch right over this junction here to our microphone socket. And that means here on pin 6 of our microphone socket we should be able to read, and there is, as you can see, no other resistor in between, so we should be able to read our 13 point something volt at pin 6. So let's do that first, okay? Okay, if we look how our socket looks like, so we can see really we have here a pin in the middle, and that one is our pin of interest. So let me relocate the camera, and now we should have everything here in view. And let's see, we should be able to read our 13 volt, but nothing at all. So let's double check if our meter is working right. So let me go down here to the board where we get here our 13 volt, and here, yeah, we have it. I hope you can read it, 13.25. so that is what we can read here, and that should be here, but it is not. It is definitely not. Okay, so that means maybe there is so something went wrong. Maybe that the owner tried another microphone, so that happens very often. And well, when here, you know, it is not soldered in the right way, so it is very easy that you short out here your voltage supply, and maybe that is what has happened. But we can do another test before we go and see, so because we really need to go down here to our front panel PCB to check what's going on down there. So first what we can do is we can try to feed in an AF signal and see if we will be able to modulate our radio to make sure that the radio in general is working, right? Okay, but first let's try if the radio itself is putting out a carrier, because you know that of course could be a problem as well. I mean, definitely we have the missing voltage at our microphone socket, but anyways, so let me switch the radio to FM, and we know with FM we should minimum be able to read our output power, so that is what we want to try, and you may see it. So let me go a little bit closer that we all see what's going on, and you see, yeah, I'm able to put out power, so, and I can adjust my power, so very fine. So that is here with our power adjust. I'm definitely able to adjust it down to 4.3 watt. Very nice. So we know that obviously our power stages and frequency generation and what have we is working in a way. I mean, we do not completely know if everything is working fine in the TX pass, but what we know now is that we have output power. But on FM, you know, it is not so easy to see by simply whistling into the microphone that there is audio. So therefore we go back to upper sideband, right? And again, nothing, definitely nothing at all. And therefore let's try to modulate it externally. Okay, and because we have our schematic, we know where we have here our audio line, and I have here connected my audio generator to our microphone to feed in an external AF signal. Okay, so and what you see here is that I set it to 1 kilohertz, so you know that is a normal test frequency for our radios, and therefore of course I've set it to 1 kilohertz sine wave, and now let's see if that will work. Okay, and therefore let me set here our waveform power mode to see both our power and the waveform. And therefore, okay, I go down to the microphone to press PTT, and remember we have set the radio back to SSB upper sideband, and now I press PTT, and yes, so it is now totally over modulated, of course, so that is for sure here, and you see it is so sensitive, so we are able to see the signal here, but yes, we definitely have here audio, and that is clearly telling me that we have lost only, in brackets only, our voltage supply towards our microphone jack here. Okay, and to get here a better pattern, I have adjusted here my audio level a little bit down, and have a look. So that is how it looks like now. So I can of course here increase my output power, as you can see, and of course I can here increase a little bit here my audio, and I can reduce it, right? So now it is very little, the audio, and now you see it's getting stronger. So that is what we can do, of course, and now you see it is much better what we have here on the screen. So that is just for demonstration, right? Okay, so our next step now will be to get here at our front PCB to see where we get our voltage feed here into our microphone jack, and we need to see where we are losing our voltage. Well, if we look here from the back side to our front panel PCB, we do not really see much. I mean, yeah, you see the LEDs which has been converted here to the radio. What we see as well here is our microprocessor, right? But well, yeah, there are a lot of components here on the PCB for sure, but yeah, to be honest, I do not really see something here. So it is overcrowded here by all the wires, and well, our microphone socket is let me see if we can get it in. Our microphone socket is down there. Hope you can see it, but well, that is all we can see here, and therefore first, yeah, let's go back to our schematic. That sounds like a plan. Okay, and what we already know by now is that when we switch here our power switch, everything is working fine, no problem. But there is definitely no modulation, so that means the audio is not getting out, or with other words, our DC is not coming up, because what we have seen when we follow here, oh, you can't see it, hang on a second, yeah, that way. That is our microphone, right? And the audio pass is here over this little cap, which is, by the way, here the DC blocking cap, so that there is no DC going down into the audio pass, right? What we have done is we simply feed here in one our audio signal, and yeah, when we go over to here, we see that directly behind here our pin 1. Hope you can see it. Let me enlarge it a little bit further. So you see that we have here our mic gain pot, and we know that we can adjust our mic gain, so that all is definitely fine without a problem, and we can get our audio down to the radio, and then it is working. So again, that means we are obviously really talking only about our voltage supply, and that comes here over our switch and the junction here to 6, and there is a little coil, and that coil is suspected, so the L404, and that is a coil I just want to check, because I guess that that might have been shorted to ground, and thus, you know, it is very easy to kill, you know, a little coil like this, because when we look over here, so there are ground connections here directly at our socket, and therefore, yeah, you can see it here as well. 5 is directly connected to ground, and if you short these both pins, yeah, very easy that you have killed something, you have burned something in the radio, and therefore now it is getting a little bit difficult, because we need to find here our L404. Okay, and I'm lucky, so I do have here our front panel PCB, the layout, and well, we have to go here to the right side, because in that area here we should have our microphone socket, and let me enlarge it here that we see something, and here we have a couple of L's, and what was the one we are looking for? So we are looking for L404, right? And there is L404. So now I'm curious if I'm able to get down to the test point to be able to read the voltage down there. Oh wow, I believe that is very hard to see. So let's see if yeah, when I zoom in, maybe you see here else, and yeah, but it is here very hard to see, so it is even very difficult to get down here with my probe, so that not that is no fun. So maybe we should try something different. Yeah, maybe it is easier. I mean, in any case, I need to have access to the board, so therefore it will not make any difference. So maybe I simply try to get here our complete front panel off to get a better access here to the board, and then it might be easier. So let me simply loosen here the screws, and then I hope I can pull it a little bit to me to be able to get a better overview. Well, you already may have noticed that that is not really a very difficult repair, but it is very time consuming because now I had to take off here our button lid simply to get access here to these screws which we need to take off in order to get our front panel off, and therefore you see, yeah, it is simply time consuming. That is more the point than anything else. And let me show you another issue what you are facing. So you see all the wires here, and you would think that we have here a connector which we can take off in order to get here our front panel away. But no, they are really soldered to the board. So that is no connector which you can simply pull off. No way. And here it is soldered as here as well, so no way. And everything is soldered here to the board, and yeah, that is really no fun. Yeah, and so let's see how we can manage that, because simply because let me try to show it. Yeah, that is all I can do here, right? That is really all I can do. I'm not able to get it here in any way away from our chassis. And you know, I need to get down here to this area. So that is what I mean when I say it is not a difficult fault, but it is very, very time consuming. And see how funny this looks here. Yeah, but that is the only way to really get down there where we need to test. And therefore now we can zoom in here. Let's see. And yeah, we can see, but I'm not enough here over to this position. And now you see we have, of course, here our 4 L's, our little coils. And what we know so far is that our middle pin, so that one here is the one which should have our 13 point something volt. And when we follow along here our trace, so we find this component, which is of course an L. That means a little coil. And now we can test the coil for continuity, right? And that is what we're gonna do now. Okay, and I've here my trusty Agilent, and I switch it to beep. Okay, and normally this little coils should show on DC continuity, which we have it here, and as we have it here. And now this one, so the third is the one which is supplying here our DC. And let's see. Yeah, and that is Gonski. Yeah, that is gone for sure. That is dead. You can see it. So let's take the last one here, and yeah, so you see that is showing a clear continuity, and this is toasted. So, and that is definitely the reason why we do not have our voltage present at our microphone. So now it is getting more fun because I have to get this SMD part out. And yeah, I think I will use my micro tweezer for the job, and then let's see what kind of replacement part I have in stock. Okay, I try to do it here. Let's see. I believe my tweezer is not hot, so 1 second. Alright, so now my tweezer should be fine, and now let's try if I can pick it here, even when I see almost nothing. So it's a blind flight, so to say. Wow, that is here. Ah, okay, so I've got it. It's off. Very nice. So that is definitely very good. So it is. Where is it? Down there. That is our component. So let's test it once again. Okay, so let's try it. So that is on beeper, and yeah, that is dead. It is dead for sure, so no doubt. Okay, so let's see what I have to replace it here. Okay, so we need a 4.7 microhenry, and I have 4.7 microhenry. It is a little bit different form, but since we do not really have a lot of current which is flowing here through the circuit, we can use this. It's a little bit smaller in size, but yeah, as you know, a microphone, electric microphone does not need so much current, so therefore we can use you know, the little one here and feed it in. I mean, I have another size like this here, but that is 10 micros, and yeah, if not other possible, we could use it, but first let's try to use the original value of 4.7 microhenry, and let's see how it works out. Okay, sorry guys, due to the situation here on the board, I cannot do it on camera, so it will be already a nightmare to get it in here with you know, this situation here. Well, so sorry, I do it off camera. Alright, so our new component is in, and now let's check if you know, we have continuity, and yes, we have, and now we should have continuity here to our middle pin, and yes, we have, and now the other has continuity as well as our new one. So that means let's try to bring the front panel back in its position, and let's try if it is working. Okay, so everything is back so far. What is left is of course we have to test it, and you see I've set here the radio to upper sideband, and yeah, let me reposition the camera that we see our LP500. Okay, and here it is. So microphone, I press the microphone, and 1 2 1 2 1 2. So you already can see that it is working. So let me go closer here to the meter. Hang on a second. Okay, let's see once again. 1 2 1 2, and you see 21 watt, 21 watt. Hola, audio. So you see it is working as it should. So very fine. The unit is back working, obviously. Okay, and for all of you who might see the voltage, which should now, of course, at pin 6. So let me carefully go down to the pin, and here it is. 13.18 volt is now back present here at pin 6. So you see, whatever you do with any microphone, be careful if something is wrong with the microphone, because you have bought it wrong wired, or you did a mistake, or whatever. So you really can simply blow your radio, as you've seen it here. And again, also it is not a very difficult repair, so that was quite easy, right? But you have seen it is very time consuming, and then additional to that, because how the radio was built, it is difficult to go down to the component. So you need some special tools to do this job. And well, if you bring a radio like this into your radio repair shop, so that is minimum 1 hour labor you have to pay. So therefore be careful if you are not able to do jobs like this by your own. Okay, so that is it. So we are at the end of our video. Of course, I have to put down all the lids, and they have to close the enclosure and what have we. But that is too boring to put it here into the video. So thanks for watching, and catch you next time. Bye.